Hello everyone, welcome to the Sea Power Report. Today's topic, how do modern torpedoes hunt and destroy enemy warships? Torpedoes remain one of the most potent threats to surface combatants in naval warfare. Despite advances in anti-ship missile systems, electronic warfare, and satellite surveillance and targeting, the torpedo, especially the more modern variants, continue to be one of the more lethal anti-ship weaponry. In today's video, we examine how torpedoes acquire and engage opposing warships, and we explain the two main classes of modern torpedoes, which are lightweight and heavyweight torpedoes. Lightweight torpedoes are mainly used for anti-submarine warfare, while heavyweight torpedoes tend to be fired by the submarines themselves against surface warships and other submarines. Then we look at the impact of each class of torpedoes against different types of warships, from small corvettes to large surface combatants like a destroyer to an aircraft carrier. We examine how the consequences from the torpedo impact can differ significantly across different ship types. So let's get right into it. So how do torpedoes detect, identify, and then home in on their target? To appreciate their lethality, it's crucial to understand how modern torpedoes locate their prey. Once launched, whether from a submarine, a warship, or an aircraft, a modern torpedo transitions from a cruising underwater cylinder to a sophisticated underwater guided missile. The torpedoes you see nowadays employ a wide variety of guidance technologies, primarily based around acoustic guidance, to find and then home in on surface warships. Initial guidance typically involves pre-programmed coordinates provided by the launch platform, which finds the target using their sonar, or in the case of aircraft, vis-a-vis a surface warship via their radar systems. By using these high-level coordinates provided by the launch platform, whether that be a submarine or an aircraft, the torpedo heads in the general direction of the target. During the early phases of the torpedo's journey, its direction might be guided by wire guidance, most commonly fiber optic. This wire guidance allows for real-time updates and change of direction if required, which is particularly useful if the target continues to change its own direction and speed. As the torpedo closes in on the target's general vicinity, it enters what we call the terminal phase, where it switches on its own onboard terminal guidance. The inbuilt terminal guidance of the torpedo involves a combination of active and passive acoustic sensors, or sonars. Passive sonar guidance relies on the sound emitted by the target itself. Passive guidance does not emit any sound of its own. This form of guidance relies on the signature produced by the target's machinery, onboard electronic systems, propulsion, and especially propeller cavitation. In contrast, active sonar guidance emits a sound shockwave of its own from the torpedo, which then hits the target and then reflects back into the transmitter. The torpedo's onboard computer then analyzes the sound wave's return to find the precise location of the target and to provide ranging and bearing for the fire control solution. Most modern torpedoes will have a combination of both active and passive acoustic homing in the terminal phase, with the capability to switch between different forms of guidance systems depending on the situation and the countermeasures deployed by the target. One of the most able forms of torpedo homing system is wake homing, which enables the torpedo to detect and follow the wake turbulence of a target's vessel, basically the trail of bubbles following the ship's propeller. In other words, cavitation. Cavitation occurs when the large trail of bubbles left behind by the ship's propeller collapses in the water. The implosion of these bubbles creates large shock waves and noise. Wake homing torpedoes follow the sound emitted by these bubbles as they collapse to find and home in on the target's warship. The wake of a ship, the trail of bubble it produces, and the associated cavitation are something that are very difficult to mask. These make it very difficult to spoof or trick wake-guided torpedoes with traditional acoustic decoys or countermeasures. So wake guidance remains one of the most effective torpedo guidance technology. Now let's talk about the two very distinct classes of torpedoes. These represent two very different forms of undersea weapons. The first is lightweight torpedo, and the other one is the heavyweight torpedo. They are differentiated primarily by their intended targets and launch platforms. Lightweight torpedoes are typically 324 millimeters in diameter and approximately 3 meters in length. They are designed almost exclusively for anti-submarine warfare, and they are primarily deployed by surface combatants, helicopters, and maritime patrol aircraft. Lightweight torpedoes prioritizes speed and flexibility as opposed to destructive power, because you don't actually need that large of a warhead to destroy a submarine, which is already under a vast amount of pressure while submerged. The warhead of a lightweight torpedo is only around 50 kilograms in weight, so they are only designed to disable or destroy submarines rather than the much larger surface warship. However, this is not to say that lightweight torpedoes cannot be deployed against surface warships if the right opportunities arise. For example, you can well imagine an anti-submarine aircraft, for example a helicopter or a maritime patrol aircraft, finding a relatively small surface warship of the enemy, those without substantial air defenses. The helicopter or the plane may find a small ASW corvette, those with only point defenses as opposed to medium-range or long-range air defense. In these situations, the helicopter may be emboldened to fire its torpedo at the enemy warship, taking comfort in the knowledge that the enemy ship has no effective way of retaliating, so long as the helicopter keeps its distance. That distance, of course, will have to be very short, because most lightweight torpedoes only have a range of around 10 kilometers. Another suitable target for aircraft armed with lightweight torpedoes are those fast attack missile corvettes. Those also typically don't have very substantive air defenses. So you can see that under ideal conditions and against ideal targets, lightweight torpedoes can theoretically be used opportunistically against surface combatants by ASW aircraft. Examples of lightweight torpedoes in service include the US Navy's Mark 54 lightweight torpedo, in use by the Arleigh-Burke-class destroyers, and the Franco-Italian MU-90 Impact, used by the Frame-class frigate. The Mark 54 has a larger warhead, but the Franco-Italian MU-90 has a longer range. By contrast, heavyweight torpedoes are substantially larger and much more powerful. They're typically 533 millimeters in diameter, although certain old Soviet torpedoes can reach up to even 650 millimeters in diameter, and they generally exceed 6 meters in length. These weapons are overwhelmingly launched by submarines and a small number of surface warships. They are designed to engage high-value targets such as aircraft carriers, large surface combatants, and enemy submarines. They have a much larger warhead than lightweight torpedoes. The heavyweight torpedoes have a warhead often around 300 kilograms, many times the 50 kilograms of lightweight torpedoes. Therefore, the destructive power is much greater. Heavyweight torpedoes are engineered for long-range engagements with a far longer range of between 40 to 60 kilometers for the modern variant. The heavyweight torpedoes that are in widespread use across the world include the US Navy's Mark 48 torpedo, the Russian Physic 1, and the Chinese U-6 and the U-9. So what happens when each type of torpedoes hit an enemy warship? Let's start with lightweight torpedoes. It's important to note that, unlike heavyweight torpedoes, lightweight torpedoes do not typically aim for under-keel explosions. They do not explode beneath an enemy ship. The usual mode of attack for a lightweight torpedo is direct detonation or proximity detonation near the hull of the enemy ship, either at around or below the waterline, rather than under the keel. This is because lightweight torpedoes are primarily designed for anti-submarine warfare. Submarines do not have the kind of flat keel surfaces that surface warships have. Because of this, lightweight torpedoes are optimized to strike at the sides or the undersides of a vessel, such as a submarine. The impact of a lightweight torpedo with a relatively small warhead would depend on the class of the opposing warship. Against relatively small warships, such as corvette or frigate, the impact can often be devastating. Small warships are generally built out of lighter materials and are less compartmentalized compared to large surface combatants. In these cases, even just a single hit from a lightweight torpedo can often cause mission-ending damage. Any hit around the propulsion of the ship can disable the engine or the steering gear, causing the ship to become immobile, or at least substantially slowed in terms of speed. Of course, any breach of the hull can lead to substantial flooding, and this is worsened by the limited compartmentalization on smaller ships. And because ships, such as a corvette, are much smaller in volume, any hit is much more likely to damage critical functions, such as the engine or the gearbox. So, a torpedo hit against the smaller surface combatants can often be devastating, even in the case of lightweight torpedoes. Against the larger surface combatants, such as a destroyer, the impact of a lightweight torpedo is more nuanced, and probably not as devastating. Larger surface combatants are generally made out of stronger materials, and they have more compartmentalization to deal with flooding. So, the damage on an overall level is unlikely to sink the ship. However, the damage will be more localized and may be severe for the parts of the ship that have been hit by the torpedo. For example, a hit near the engineering room might disable the engine and the gearbox, in turn immobilizing the ship. And a hit near the bow sonar, near the bulbous bow, or near the stern where the towed sonar are located, can destroy the ship's sonar capabilities, rendering them a sitting target for any nearby submarines. So while the overall damage might be more manageable and more survivable, it still could be quite severe for the parts of the ship that are affected by the impact. And the destroyer might require towing back to the dry dock for repairs. A large warship, such as an aircraft carrier or a large amphibious assault ship, is highly unlikely to be severely damaged by a lightweight torpedo hit. However, they will still suffer a certain degree of damage in the areas affected by the impact. For example, a well-placed hit could flood the propulsion areas, or damage or destroy the propeller. The intrusion of water into electrical compartments can cause the failure of certain systems. So there will still be a degree of damage, but it is highly unlikely for a lightweight torpedo to sink an aircraft carrier or other large warships. Now, what happens when a heavyweight torpedo hits a naval ship? Well, that's a totally different ballgame. Heavyweight torpedo hits are devastating. Heavyweight torpedoes are designed to kill a ship outright. Unlike the lightweight torpedoes that impact the side of the hull, heavyweight torpedoes generally aim for under-keel detonation. This approach exploits a fundamental structural vulnerability of a ship. Heavy torpedoes rely on proximity detonation to explode beneath the keel of the ship without even impacting the actual surface. The detonation displaces a massive amount of water, creating a massive gas bubble underneath the keel that forces the ship upwards. When that happens, everything inside the ship shakes violently, including the machinery, the electronics, and of course the crew members, who are highly likely to suffer severe injuries or death. When the gas bubble beneath the ship collapses, the ship then drops into the resulting vacuum, and the hull of the ship may start to bend. In certain cases, for smaller ships, the hull may well snap into two. This has been demonstrated by live-fire tests of heavy torpedoes in naval exercises, and this is the standard kill mechanism for a submarine-launched torpedo. In simulations and live testing, the under-keel detonations by heavy torpedoes have the potential to instantaneously sink any surface combatants, up to and including the size of a destroyer. If the ship wasn't sank outright, it was highly likely to be permanently crippled and to sink shortly afterwards. The real question is, would a heavyweight torpedo sink an aircraft carrier or ships the size of a carrier? Well, there's a certain degree of uncertainty around that. Supercarriers, due to their size and compartmentalization, is probably less likely to be sunk outright by a single heavyweight torpedo hit, but they remain highly vulnerable. A single hit may still result in a loss of mobility, or at least a substantial slowdown in speed for the carrier. You may also see a cascade of the failure of internal systems via short-circuiting and the rupturing of internal pipelines, or more. This may not result in a total loss outright, but it would result in a certain level of paralysis, opening up the carrier to further follow-up hit from more heavyweight torpedoes launched by the same submarine. If a submarine got close enough to launch a heavyweight torpedo at the carrier, it is likely that they won't just launch a single torpedo. Rather, there is likely to be several torpedoes coming at the carrier, so further hit will likely follow up the initial hit. And multiple successive hits from heavy torpedoes within a short time frame is very likely to sink the aircraft carrier. So heavyweight torpedoes pose a very real threat to aircraft carriers, despite the high level of resilience built into such warships. In this video, we discuss the main ways for torpedoes to identify and home in on their target. These guidance systems all fall under the umbrella of acoustic guidance. They are passive acoustic guidance, which relies on tracking the sound emitted by the target. There's active guidance, where the torpedo's own guidance system emits its own sound wave, and using that to track the target's location. Wake homing is a subset of passive acoustic guidance, and is one of the most effective ways for modern torpedoes to find their target. We then discussed the two main classes of modern torpedoes, which are lightweight torpedoes, which are generally used to attack submarines, and heavyweight torpedoes, which are used also against submarines, but also against large surface warships, up to and including aircraft carriers. We then analyzed the consequences of the hit by different classes of torpedoes on different types of warships, from small corvettes to large surface combatants, and finally, the super carriers. We found that, unsurprisingly, the under-keel detonation by heavyweight torpedoes posed the greatest threat to surface warships. That will be all. See you next time.